Hi, I'm Paul Battaglia, and this is section 8.10. Take a deep breath. It's been a long section, certainly for students, and I'm sure for you as well. Think about all the things that we've covered. Power series, geometric series. We've talked about Taylor polynomials, various tests for convergence. Well, now what we'd like to do is just finish up by talking specifically about those Taylor polynomials and how they project into series. So the essential question we would like students to be able to answer at the end of section 8.10 is, how do I find a Taylor and or a Maclaurin series? I really want to focus in on example 3 because I think it underscores the importance of why students must know some of the elementary functions in the series that go along with them. Now, specifically in example 3, we're asked to manipulate the series and find a resulting series for sine of x squared. So what I like to do is I actually like to ask students as their warm-up for this section to give me the first 5 non-zero terms for the series for sine of x from memory. So they don't know I'm going to ask this, but when they walk in the classroom, we're going to see just how good they've been doing in committing them to memory. So hopefully we get somebody to come up and put it on the board correctly, and we have the first 5 terms or so. And you could really pick any amount of terms. Then I say to them, okay, so we're saying that sine of x is equivalent to this series. What would it be like if I asked you to find the series for sine of, and then I just draw a heart? And they laugh and they chuckle a little bit, but then the reality sets in that I didn't really ask them to do too much, and we go back all the way to basic algebraic rules. Whatever I do to one side, I have to do to the other side. So if I remove this x and replaced it with a heart, what must I do to keep these things equivalent? Well, on the right-hand side, every single time I see that x, I have to replace it with a heart. So I say, okay, now we're ready, and I go to example 3. What would the series look like if it was sine of x squared? Now for them, this substitution is seamless. But again, it's more efficient if they know the series for sine. Think about, I tell them, think about if you didn't know that at the top of your head, this is what the series looked like. Think about what you would have to do to just try and recreate sine, let alone sine of x squared. It'd be way too difficult. Okay, so then I actually do note that in examples 4 and 5, we're dealing with binomial series. It's not something that the students need to know for the AP exam. And it's great to look at, but think about where you are in your year. We're nearing the end of the course. We have one more chapter to go. And if there's any time that we're going to have to actually cut some things down, probably is now. So don't feel bad about not looking at those examples. Maybe perhaps you want to save them for after the AP exam. Now, what I really like about examples 7 and 8 is it gives a teacher a chance to see if any of the students are having issues with manipulating the series and such. Specifically, example 8, great example, because if I ask them for the series of tangent of x, they're probably going to look at me and say, well, have we done that? I feel like we have. And the reality is we probably have not. We've done sine, we've done cosine, we've done some other things, but now it's time to actually look at how we can try and discover and create this series for tangent out of what we already know. Again, I'll go back to the efficiency idea. Do we want to sit here and do we want to find all these derivatives of tangent and try and find the values that way? Or do we want to use what we know? And we know that tangent is equal to sine over cosine. So sometimes they'll ask, is it really that easy? Do I really just have to put one series over the other? And my answer is, well, yeah, it is that easy. Now, the division isn't quite so easy, but it's something that we can certainly do to at least get the process started. Here's a great closure activity. In fact, it's really a great way not only to bring the section and the chapter to a close, but really to connect back to something that we saw what probably feels like light years ago in chapter 1. Ask the students to take that series for sine of x and give the representation for sine of x over x. Now, I'm sure you'll have some students who are thinking to themselves, well, we've seen this before, and certainly we have. Chapter 1, we looked at this as a special trigonometric limit. Later on, in chapter 7, we looked at how to work with L'Hopital's rule to verify this limit. So the limit as x approaches 0 of sine of x over x is 1. So students now create the representation, the polynomial that we're going to use to represent sine of x over x. And I say, okay, let's get those graphing utilities out. And in the first function area, I want you to put in sine of x over x. But in y2, I want you to put in this new polynomial. Now I have to specify how many terms I want, so maybe we'll keep it simple. We'll just go the first 3 non-zero terms. And once we do this, I say, okay, take a look at either the graph or the table? Tell me if you notice anything. And if they actually look carefully, they're going to see that even with only 3 terms, that the functions don't even look any different. And when they go to the table, the values are matching up. I mean, what a powerful aha moment, connecting something that we talked about months ago. And here we are at the end of the class saying, yeah, these ideas are pretty much the same. I mean, it's just a great way to get students thinking, and this is exactly how they have to think in order to be successful in the course and, of course, on the AP exam. So to finish up, if you're looking for a little bit more practice for students, having them manipulate more things and maybe even giving them problems or examples that might be a little bit more quote-unquote AP-ish, take a look at the end of chapter AP Review Spread, specifically examples 9 and 10. They do a great job of showing students exactly how we have to be ready to work with these elementary functions. I hope these tips have been helpful. I'm sure you'll find much success in section 8.10.